In this tutorial, we shall try to simulate the heat flow of an electric heating element. So, first things first, we try to design the actual heating element. So just a basic sketch of how the design was going to look like. We're not going to sketch it. We're not going to dimension it. Right. So it's going to be like a pitchfork with four. It's going to be like a pitchfork with four prongs. All right. So yeah, this one. Let's do. That's 3, and that should be number 4. Okay, that's done. And now we can at least try to give it some dimensions. I think the top parts of the prongs could have I think just 25 millimeters would be alright. For all 4 of them. And if my voice kind of sounds a bit weird, it's because I'm coming down with malaria and the flu, so yeah. Okay, that should also be 25. Okay, I feel the overall height should be like 160. Okay, so that's 25 by 160. Okay, I feel the inner parts can be 20 each, so it's going to be 25 by 20. Everything else should be able to solve itself proper. And so by default, the very last one should be 20 as well. So once we dimension it, to give us an error of over dimensioning it, so you can just leave it. And I feel the length of each prong of all the prongs, we can just give it not the length, the height. 60. 75 is a bit too much. I feel 60 would work best. And we can just undo that. And give it a distance of 60. And the bottom one, same distance of 60, which will automatically put everything in line. Okay, so everything is properly dimension. Just that part left, I think that just 80. I feel 80 would do. Alright, so we're going to introduce something. It's called the swept boss base. We can go by our features and we can go by Alright, so before we do that, I forgot something which is, okay, not forgot, something we shouldn't do at the start of every excuse me, at the start of every tutorial, which is to give the material, and the material we're using, and in this case it's a heating element. The material we're going to be using is, it can either be chromium, it can be nickel. I feel we're going to use nickel for this one. I've been trying to search for chromium. I don't know what's happening here, but it seems my Solidworks is acting up. It's not giving me the chromium I'm looking for. I think we can just click OK. For you, I'm sure it will give you something different. I think there's something wrong with, I was dealing with another design. So there is nickel there, and that's the one we're going to go for. Alright, so I mentioned before we would introduce a new feature, a new command, which is the swapped bros base. You can just click on it. Right, since what we're trying to create is a circular profile, we can just click on and then click on any line, and it will give us something like that. Nice, but I feel that's a bit, yeah, I think we can at least be able to modify it. So we can click on our sketch, and sketch 1 just below the origin, and we can click on edit design. So I click on sketch 1 and click on edit sketch. Alright, then we can go on our fillet, sketch fillet, and then we can at least be able to give it some fillets. So meaning we can give the outside fillets just a diameter of 10. Right, we can give the outside fillet diameters of 10. Okay, and then the ones on the prong side, we can give them diameters of 7.5. Right. 1, 2, 3. Okay, and then the inside ones we can just give them a diameter of, I think just 5. I think a difference of 2.5 in descending order is okay. Okay, I think that seems a bit better. Okay, we can just click OK on the swept, on the fillet, and then we can just go back to our swept pro space. Same procedure, circular profile, any line, and I think that looks a little bit more realistic of a typical heating element. I'm sure you'll be able to notice just down there that the diameter is 10 millimeters, and you can click OK. Okay, that looks, so that's a basic heating element. It's just a basic sketch. Okay, so we can go on simulation, new study. This time it's a thermal study, so we just click on thermal, and we can edit it. We can make our design a bit unique, but for this one it's just going to be a basic one, so we're going to pretty much ignore any other kinds of power and stuff like that. We're just going to focus on the heat flow through the heating element. So we're just going to go for the thermal loads, and I'm going to click on the temperature, and then we're just going to focus on the parts that are going to be causing heat, right? How the heat will be flowing. So you can change the temperature from degrees Celsius from Kelvin to degrees, and then you can just give it a basic temperature of 100. And I feel we can can select the parts that we expect heat or we want to conduct heat. In this case, it's just pretty much everything except for the two end plates. Right, just that plate and that plate, that's pretty much where the power will be coming from. Right, you can click on thermal loads again. No, not on the temperature, but on the thermal loads, and this time you can go on convection. And this time around, it's those two end plates that we're going to click, because those are the parts that are going to be causing, that's where the heat will be coming from. The convection current of nickel, every metal has got its own default convection current, but I feel I've forgotten that one for nickel. It should be like 50, between 50 and 75. And our ambient temperature, I think should be 22. It's just the room temperature basically. It could be different based on where you are. I think it's 22, so 22 plus 273 should give us something like 295.95. Yeah, in Kelvin. Okay, and then we can click next. Okay, so next up we can click on mesh and then go for mesh and run, and then the computer itself will start calculating. Right, so I feel I should mention that the delay in the MATLAB videos has been mainly because of how I've been feeling the past few days, but I've definitely been working on them, and the videos will start coming up on the channel. I'm hoping next week. If not next week, then the other week. Alright, so it started solving, and there we have it. Okay, so what we can see from here is that at a temperature of 100 degrees, pretty much everything, the entire heating element becomes hot. Right, you can see the scale there, so which means let's just be able to see how it's flowing. Yeah, we can click on temperature, and then we can see this is how the heat is flowing from the two end plates. That's how it's flowing, causing the entire heating element to become hot, to become red hot. Alright, that's quite neat. Alright, basic design. We're definitely going to continue doing a bit more complex designs. We're going to include more things, we're going to include more stuff, so we can save it. Okay, that's done. And just like with what we did in our previous video when we were looking at the force flows, we can simply be able to do a report just by clicking on report. It can generate a full report and be able to talk about everything that we've dealt with in this specific video. I don't think we'll be doing that today, but yeah, I think that's it for this video. Thank you very much for watching. Please leave a like, subscribe, and don't forget to share. Have a great day.